Hi, welcome to everyone's favourite segment, Mailbag. Please forgive my voice, I'm still not that terrific. Open immediately from Fran Blanche. Everyone knows Fran. If you don't know, subscribe to Fran, LinkedIn down below. Anyway, everyone already knows Fran. Let's open it immediately. We have a note. It's not typewritten. I'm used to... Hey Dave, I thought you would appreciate this as much as I do. Wear it well. Thank you very much, Fran. It's even protected with cardboard. Let's have a look. Ta-da. Oh, she sent me one. She sent me one. This is brilliant. All right, you've got to see the video where it's like an hour long how she makes this. Hang on. I've got to turn the lights off. Sorry, but this might be the best I can do. This is the best blacklight torch I've got. Unfortunately, my good one is missing in action in the lab move. So, no good. How's that? Look at that. It's a DSKY display. And if you don't know, the DSKY is the user interface to the Apollo guidance computer. And Fran spent an awful amount of effort to do all the custom silk screens and everything to get this t-shirt manufactured. Highly recommend you watch the video of her process of making this. This is fantastic. Sorry I can't do it better justice here, but that's just great. So yeah, apparently it's really difficult to manufacture shirts like this that actually are luminescent like this. And Fran actually did it all herself. All the chemicals, the whole works to actually get this thing done. Brilliant. Thanks, Fran. This one, I unfortunately opened. If you're going to send something into the mailbag, make sure it says mailbag on it, because I get a ton of stuff, like I've ordered stuff, or people or other manufacturers sent me stuff that's not mailbag things, and if it hasn't got mailbag on it, I'm just going to open it. Oh, what have I forgotten that I've ordered this week? And I rip it open and, that obviously looks like a mailbag thing. So this one was obviously a mailbag thing. It's the voice command for oscilloscopes. Beautiful. Comes in a very nice little case. I like it. Anyway, that looks really cool. Let's see if we can command our oscilloscope. I'm sorry, Dave. I can't do that. All right, what we got here is Ollie. It's a voice control for oscilloscopes, and that's just a regular Raspberry Pi down there. So the Ollie is the board on top here, and the open source software that goes along with it, and it basically contains, it's got dual microphones there. Don't know why it has to be that newfangled stereo rubbish. I thought one microphone would have been fine. Anyway, get some added discrimination, I guess. And there's just one push button on it, but I don't know what that does yet. And supposed to control your oscilloscope. It's on the GitHub, and his user JMW on the forum, and it works currently with Keysight MSO 1000 to 6000 series, Rigol MS and DSO series scopes, excluding the new one, I guess. Anyway, you're supposed to just be able to plug it in and then go, hey, snips. See, it just came on. Hey, snips. And it recognizes, don't know why it's flashing twice. Anyway, so it seems to be working so far, and you just go, hey snips, single, and it puts your oscilloscope in single shot capture mode. That's the idea behind this. And it's got a whole bunch of different commands: run, stop, single, all that sort of stuff. So, hide external trigger, show digital zero, zoom in, zoom out, set time base to 100 nanoseconds. I wonder if it's going to recognize my Aussie accent. She'll be right, mate. No worries. Of course, the whole idea behind voice probe in your oscilloscope is if you're probing your board, imagine there's a board there and you're trying to dick around. Well, you got your tongue at the right angle, you're probing the pin like this, and you've got your one hand over here operating your silly scope, and it's a real pain in the butt. Wouldn't it be good if you could just go, hey, snips, single, and it's set to single shot capture mode? That'd be pretty cool. Well, let's try it out. There's the complete board for those playing along at home. Can't see what that micro is down in there, so it's just hard to read these chips on the stupid camcorder LCD. Anyway, yeah, that's all you need. Hey, snips. It recognizes me so far anyway. I believe that's correct. Then it just uses the USB on the Raspberry Pi, and that just connects to your USB on your scope. So you don't need any of that newfangled Ethernet rubbish. You can just hook it in. Almost all scopes these days have, well, at least these ones do, have the USB device option. And you plug it straight in, and it's supposed to red if it can't detect, and then you plug in your scope, and if it has detected a scope which it recognizes, 3 greens briefly. There you go, and it should be good to go. Let's try it. So I've got my waveform here. Obviously we can go into single shot capture mode. It's just some serial data. So let's give that a whirl. Oh, hang on. I think I didn't say hey snips, and it had popped up with the command there. So I assume it just does all those 3 lights if it didn't recognize a command. Anyway, let's go try and put it into single shot mode. Hey snips, single. Yep, there you go, bingo, single shot capture mode. But that wasn't very quick. Let's try that again. Hey snips, single. That took a good 2.5 seconds or something like that to register, and well, that's cute, it works, but yeah, I don't know. Let's put it back into run mode. Hey snips, run. That's pretty good. Recognizing my Aussie accent, it works, but there's a bit of a delay there, and when you're trying to single shot capture stuff, well, that could be annoying. Hey snips, what's the frequency on channel 1? Hey, look at that. Frequency, channel 1. Look, the cursor's popped up. Beautiful. Didn't call up the hardware frequency counter, but that's terrific. That worked. That was a fairly complex sentence it had to recognize this Aussie accent for. Hey, snips. Show there. Hey snips, show blah, and it showed up the math function. I love it. Yeah. Let's try that again, one more time for the dummies. Hey snips, show channel 2. Yay, channel 2, brilliant. So it works. Hey snips, zoom in. Hey, change the time base. Hey snips, zoom out. Cool. Hey snips, make channel 1 smaller. Yay! It's under my command. Hey snips, what's the duty cycle for channel 1? Duty cycle. Brilliant. Hey snips, clear all measurements. Oh, look at that. Beautiful. Winner, winner, chicken dinner. I'm surprised out of the box that it actually recognizes my Aussie voice. Seems to do a decent job of it. So that's pretty cool. Well done. So I'm going to link in this down below, and of course you can build it yourself. It's all open source. So there you go. If you've got a Raspberry Pi lying around, you might be able to buy a blank board or just buy the board on its own. I'm not sure what the deal is there, but that's pretty groovy. I'm kind of impressed by that. I wouldn't use it in practice unless I had a real specific need for it, really. But yeah, it's pretty cool. Well, it's one of those things, if you need it, you probably really need it. And a few of the manufacturers, Keysight isn't one of them, I think, but a few of the manufacturers do actually sell voice command modules for their scopes. So, yeah, it's a thing. So anyway, that's the Ollie. That is brilliant. Definitely worth giving a go anyway. It's a good curiosity. And you can actually, it's pretty much self-contained. Of course, you can power it like I am, powering it from the scope and then just plugging it into the back of the scope. In fact, if you were really keen, couldn't you power it? I think you could probably steal this and then like have it redesigned somewhat so that why couldn't it steal the power from the USB port that it's plugged into? That'd be kind of cool, wouldn't it? Anyway, it doesn't draw too much power. That can't be powered from the scope. Normally, a Raspberry Pi takes a fair bit of power, but in this particular case, my Keysight 1000X series is driving that just fine. So that's pretty groovy. And it's based on the Snips platform, which is a voice recognition system. That's probably why it's so good and so polished, because I think it's probably been around for quite some time, and it's had a lot of spit and polish done to it, and can recognise an Aussie accent. So, beauty. Hey, Snips, make Channel 1 bigger, mate. Query unterminated. For a campaign to start in May. Oops, it's the middle of June. Thank you very much. Loser LLC. Winning name, Loser. But it is actually Loser LLC. Okay, no worries. Is that the reverse psychology thing? Let's see what we got. We have a note. We have a board. Some sort of interface board. And it's a board with a round hole in it. Hi Dave, we are a group of electronics enthusiasts based in Ames, IA. Where's IA? I don't know IA. We invented an open hardware tool and wonder whether you can help us spread the word. Well, it's in the mailbag video. World's most popular segment. Okay, I think I'm getting what this is. Oh, a few bent pins. Yeah, if you're gonna whack something with pins, make sure it goes in foam, and then you tape it on the foam and then put it inside here. You can't just whack long pin things inside a box and expect them to survive postage. A little trap for young players. So Forrest has sent in the Bread Shield crowdfunding. There you go. You can read that for yourself. crowdsupply.com/loser/Bread Shield. Love it. And as the name implies, it's a shield for an Arduino Uno-y type thing. It only says only for Uno. Well, no, is that an asterisk? I don't, well, anyway. It plugs into various Arduino Uno-y things, and it just allows you to connect to the breadboard, so it breaks out your voltage, so 3.3, so you'd wire that over directly to your power strip, all the I/O and the analog and ground and everything else. If you've got your UARTs and whatnot, and I'm not sure what that connected down. Oh, okay. Oh, that's for, okay, right. That's for that. Don't know, that doesn't extend at all. So, yeah. Anyway, it comes in two versions. One's got a big circle in it, and I guess if you need access to stuff internal to the Arduino. So, there's not much more to say about that. I probably would have maybe had the option for a poly switch or something on there, just in case you're goofing around on your breadboard and you short it out. You don't want your Arduino to short out, so maybe that would have been handy. But apart from that, it does the business. That's it. That's all it does, and that's fine. Height's a smidgen off for just a regular breadboard like that, but no worries. Check it out. No, hang on, this is version 2, and this one is version 3, so I think they've changed it. So, they've changed it from 750 mils out to 800 mils, they've added the circle in the middle, and various things, so I'm not sure what the... Anyway, it is open source hardware. You can throw the board on your next order if you want one, or whatnot, so linked in down below. Do not drop, okay? You got it? Is it clear enough? Fragile? Oh, smack, straight on the end. It's guaranteed. So thank you very much, Lee Zhao Seng. I think it's a silent I in it. What is it? Engineering samples. I don't know. If you want to send stuff to avoid customs, engineering samples the ticket. That's the ticket, laddie. Or the old favourite, machine parts. Padded. Yeah. Lots of stuff. Project files. We have the project files. That looks... ST Engineering. Electronics. Looks like a very nice little notebook. Oh, black. Thank you very much. ST Engineering Electronics. Mobility. Rail mobility stuff. Nice little notebook. I like notebooks. Pen has a thing. Oh, what does that do on the end? Not sure what the end of that pen is. Looks like... Is that a lead? Does it light up? I don't understand what's in the end of that pen. I'll figure it out. Wow. Lots of tape. You're doing this deliberately, aren't you? Just to piss me off. Gotta work for it. What on earth is in here? We've got a PCB. It's a PCB with some relays on it. Spoiler alert. It's a programmable timer switch with a big ass through hole micro on it. Oh, I think I've seen this. I think they posted it on Twitter or something. That rings a bell. Ah, hi Dave, I sent you this bare board over a year ago and this is the completed unit. Soldering is ugly, but it works. There you go, it's the timer. So I've had a look at that before. Thank you very much, Lee. So this is Lee's programmable timer switch, which we have seen before, so I won't go through it again, but this is the built-up version. And once again, I still don't know why you'd go for the dip version when almost everything else on here, apart from the crystal here, even the switches are through hole, but brightness, LCD, trimmer up here, your regulator up here, it's a kind of a weird combination of through hole and surface mount. If you're gonna go surface mount, you may as well go all the way with LBJ, I think. Anyway, it's powered up. Kind of annoying that you can only power it from 9 to 12 volts DC. You can't power it from 5 volts USB. I would have put a USB on there and just bypass the reg and just power it directly. So, yeah. Right, let's see if we can operate this thing. Haven't read the instructions or anything. We've got a real-time clock calibration. I'm not sure why you'd bother. You're going to get your fit. Whoa, backlight just turned off. What? Hello? Why wouldn't you? It's plug pack powered. Why wouldn't you leave the backlight on all the time? Is that a software thing? What's going on? Menu. Yep. It's a software thing. Yeah, I wouldn't have bothered. That seems silly. Menu. Information. I would have put one of those joysticky things on here, probably. Mode. Manual. Repeatable. I have no idea what that is. Specific. Timer. Well, let's go to timer mode, shall we? Choose OK. Setting OK. Thank you. Do I just go back? I wouldn't have setting OK. Let's go back. That's it. Yeah. OK. What do we do now? Oh, no. What? I thought it said... No, ref plus... What? Seriously, I thought that said reset. And I thought that was some sort of reset button. Right, so on... What do I do? Anyway, we've got a heartbeat LED up here. Haven't seen a heartbeat LED. Yeah, it's really old school. On, off. I'm not hearing the relay go. I guess we have to go into manual mode. Time, date, okay. Oh, didn't go into that before. Master reset. So we can choose to have the relays come on a specific time, date. That's probably where you need a keypad. Oh, sorry. Couldn't see that. Mode. Choose okay. Manual. The buzzer sounds a bit sick. All right. Yeah, there we go. There we go. Yep, on, off. Yep, so we're in manual mode. That's totally exciting. And then you can program it. I won't go through, but yeah, you get the idea. So the problem I have with this is that I'm sure I would have mentioned it last time, is the size, the form factor of this. Sure, if you want to make it big for a particular reason, then that's fine. I would have had the programming header over here somewhere. Wouldn't have had it sticking over the edge like this. Would have had it vertical right near the micro, because you've got to route the traces all the way over there. So I'm not sure why you'd bother doing that. As I said, you'd just go all SMD. If you use parts that you had to hand in your junk bin, that's fine. No worries. I would have used a USB, as I said, 5 volt direct in power. And that backlight, no, you got to just leave it on all the time. Crazy. It did mention in the letter that should have used a green LCD instead of blue one, because its characters can't be seen when the backlight is turned off. It's not necessarily a factor of the blue. It's a factor of that you didn't get a transflective LCD, which means that without the backlight, you can get it's both transmissive, you can get the backlight coming through, and it's reflective as well. It's a combination of both. So yeah, it's just a particular type of LCD. You can order them in different configurations. And apart from that, I don't know, I would have had more. Can the software actually read the state of the relay? I would have, if it's on, yeah, the LEDs are coming on, maybe have it on the LCD, but I don't know. That's neither here nor there. And apart from that, yeah, I would have made it credit card size or something like that. to, I don't know, just because you could. Although, you know, you have a rather large 16:2 LCD like this, and then buttons and things like that. I guess, you know, anyway. Cool. Thank you very much, Lee. I can't remember if this is open source hardware or not. There's no, Lee doesn't give a website or anything. So, there you go. I guess I can't point you to where it's at. Oh. And also, you probably could have used, they're more expensive type, but you could also use a latch-in relay type, and then you could actually have the thing battery powered. It wouldn't take much power at all, because then it doesn't have to retain the relay. It can just latch it on or off in various states and stuff like that. So, or you could have solid state relays and things like that for some sort of, you know, battery powered version. But then you're getting into a whole product design and stuff like that. And well, you know, this is just a board that I guess Lee needed to control some stuff, and he's added flexibility to the menu for time, date, configuration, and various I don't know how you, like, is there a programming mode where you can program in sequences and stuff like that? I wasn't sure if that was a thing. Repeatable, specific, I would have, like, you know, like, yeah, it can come on and off at a certain time by the looks of it, but doesn't seem to be any, like, sequence programming mode where at a certain time, then you can run a sequence of commands, for example, like, okay, tomorrow at 8 a.m., I want this relay to turn on for 5 minutes and then turn off and then turn on again. It's kind of like the, you know, the old sprinkler timer, the water sprinkler timer for your tap, and, you know, stuff like that. It might be able to do it, not sure. Thank you, person unknown. Once again, didn't have mailbag on it, so I did open it and I instantly went, well, there you go. Yep, that looks like mailbag. Mark, thank you very much, Mark, for sending in some sort of old HP board, which he has no idea what it is. Oh, the Motorola fanboys go wild. Look at that big ceramic jobby. Very nice. So it's a HP IB. It's part of their, it's probably part of their, like, life sciences range or something like that. And it just plugs into like a Euro rack kind of thing. So that just looks like that. Well, it's a main processor. But does it only do, I mean, it's got RS422 interface, HPIB, and then it's basically, is it just the interface controller? If so, that 68,000 is a bit of a beast just for a controller. So I don't know what sort of processing that does. Aha, HP 37288A for those playing along at home. It's got 75 ohm input B and C, so obviously part of the same rack. It wouldn't just be these two. You could have probably cascade like dozens of these things. 140 megabits per second. So it's some sort of serial interface jobby. Let's take a closer look. So Mark is sending these classic HP boards, and please, if you've got details, I'm going to have to Google it and add information here. But as you can see, this one is 140 megabits per second, 75 ohm input there, not your standard 50 ohm. So that's interesting, the HP 37288A. As I said, my first guess would be one of those life sciences doodads or something like that. And as you can see, it's all LS, it's all TTL goodness, and in the class, oh no, I've got some F series, got to have some F, yes, F and LS, and then some Motorola jobbies down here. This is interesting, how the board changes. When you've got all these Motorola jobbies down here, they'd obviously be doing the serial decoding or what, the high-speed serial decoding. I'm going to have to look up the data sheet on there, but look how they've got a crosshatch grid over that. Is that their sort of attempt at sort of like adding a top flood fill shield to that? But they went, oh, we don't want to warp the board, you know, having all that copper on there. Although they did do a copper flood fill there, they probably didn't want it over the whole thing, and they just went, oh, let's, you know, not put copper over the whole thing, so we'll put crosshatch. You know, not many people do the old crosshatch anymore. It used to be very popular back in the day, and most packages can probably still do a crosshatch flood fill for you, but it was really only in the old days of PCB manufacturing. They hadn't perfected the processes yet, and the laminates, and they'd warp, and they'd cause all sorts of problems, and the solder mask would peel and crinkle, and it was really horrid. But you really don't have to worry too much about that today, although if you do have one big if you have a really large board and have one big copper on one side and then nothing on the other side, it can get a little bit how you're doing, but still, that's interesting to see. They didn't repeat that on the bottom. Oh, I got a genuine bodge. Look at that. But as is classic style, as I've mentioned many times, when you've got old school digital layouts like this, you put all the chips in the one direction like this. This is how you lay it out. You notice pin 1's all in the same orientation. They're all facing, unless you had a real specific requirement to flip a chip around, you wouldn't. That would be sacrilege. So they're all pointing in the right direction. And then on the top, you'll notice that the traces are going cross like this, although this is a multi-layer board. You can see the internal green ground plane inside there. And this one actually, interestingly, look, the ground plane stops there in the inner layer. This one maybe doesn't have that. So that's interesting. It's got the crosshatch on the top. Fascinating. I was going to say, were they trying to sandwich it in between the traces? But there's no ground plane on the bottom. Anyway, on the bottom, they all go in the vertical direction. And that's how you would route your boards back in the old days with all your digital logic before. Now it's all in a micro bloody FPGA these days. But anyway, classic old school 140 megabits line monitor. Now, I wasn't able to find any direct info on it, but I was able to find a list, and here it is, of various cards in their 73XXX type range, and it looks like it's from some sort of communications, serial comms analyzer, something like that, and that makes sense. There are the more modern versions I could find are much smaller, and they got these half-height cards that you plug in, but these full-length ones, obviously it's an older type thing. So I don't think it's a life sciences thing anymore. I think it's a specialized bit of serial interface test kit. If you do have any further information, please let us know. Anyway, all the stuff on here, we're talking, these are MECL to, ECL to TTL converters. So they're basically converting the data from all this ECL section over here to your TTL section up here. And then all your other ones, these are just ECL or MECL equivalent, I think one's a D flip-flop, and various just digital logic. Equivalent is 7.4 series TTL, but ECL faster. And there's the input section down there. Got some sort of hybrid action happening down there, and these are fascinating. Check these out. These are delay lines. Wow. And then then you choose your tap. You manually choose your tap on top, and then that just gets shorted over to the bar on the bottom, which goes down. So that wouldn't be a particularly long delay at all. We're only talking handfuls of nanoseconds there. But obviously, that's a programmable delay line. So that's really interesting. Why you'd need those? So is it some sort of calibration thing? You wouldn't think so, because once you've done your PCB layout, everything's pretty much, characterized down to 0.5 of a nanosecond. So really, I don't know. Let us know. Maybe some sort of, anyone got any info? Why you would have nanoseconds, tens of nanoseconds programmable delay on something like this. That's, it's not really the user could adjust it, but I think it's more factory programmed or something like that, perhaps. Interesting. Anyway, a couple little test sockets. They're actually little itty bitty coaxes down in there. So that's just a serial line receiver for 140 megabits, which would have been screaming back in the day. None of this gigabit rubbish. And then you've got this processor / GPIB board. As I said, I don't know whether or not it's just doing the GPIB processing. Pretty grunty processor for that. 68,000 job. Anyway, we're talking about 1988 vintage here. Oh, 83, 87, 88, yep. So late 80s vintage here, and, you know, a few F-series interface stuff with the bus over here. Not much else doing, but it does have a whole bunch of interface lights and some remote RS422 stuff, which buggers off. And there's your ROMs. So if anyone has any info on that, please let us know in the comments down below. Oh, no bodgers. Perfect layout. Thank you very much, Joseph Panini from Burlingame in California. I don't want my viewers in California. I think it's much smaller than what it looks like here. So let's have a squiz. All right. I think I know what this is. I was clued up. It is a plastic case. That's one way to do it. Thank you very much. Oh, there we go. And then shrink wrap for our protection. We have little SMT adapters. Cool. Let's check them out. So Joe's made these cool little SMD to banana plug adapters, and they're I don't think I've seen these particular sockets before. Let's have a look. This is for 0402 parts, and it's exactly what you think. It's a ZIF socket. It's a zero insertion force socket. You can see the tiny pins in there, and it converts your 0402. We've got 06, we've got 0805. We've got two 0805s, different widths, and we've got 0603 as well. And it goes inside there and you put it down. So you got to, obviously, you could get it with your finger, like 0402s, you could sort of get it maybe off the bench and put it in there, but you'd be having a hard time. So you got to put it in there with tweezers, but once it's in there, beauty, you just plug that into your meter, your multimeter or your LCR meter or whatever, your bridge, whatever you're using, old school bridge, and you can measure them very nicely. I like that. All right, it was only about 0.1 puff. It's almost practically not measurable. I'm going to see if I can get an 0603 and whack it in here. I'm going to see if I can do it the old-fashioned way. Pick it up, put it on the finger, and whack it in there. Yep, Bob's your uncle. Have a look at that down there. And just whack it in your ZIF socket, and beautiful, like I bought one. How easy is it to get out? Can you actually get it out? No! You gotta... think you gotta tip it out. Advantage of these is that they're cheap, relatively simple, and plug into your existing LCR meter or multimeter. But the downsides are they're fiddly and you've got to get the individual component in there. No good for mass testing or for testing them in reels. For those sorts of things, I much prefer one of these puppies. Look at that. Ah, beautiful. And you can you can just test things in bulk. I mean, these things aren't cheap, but you can actually get tweezer adapters like this for your LCR meter. You can probably buy them on eBay or AliExpress. Haven't actually checked, but yeah, they're better. You can actually test these in the tape and stuff like that when you're selecting components and things like that. So, you know, but real expensive solution. Much cheaper and simpler solution. So check it out at aprilog.com. Thank you very much, Hype. I'm hyped. From Hong Kong. A SAR? What's Hong Kong SAR? I feel like I should know that. Is that like in some sort of economic zone thing or something? Anyway, let's have a look what's inside here. Thank you very much. I think it came like this, or it might have, I don't know. Oh, no, that is the original Hong Kong shipping label. Anyway, let's have a squiz. I don't think it didn't have somebody's name. It just said from Hype. Hi, I got this MKU thing in new in-box condition. Unfortunately, it didn't work when plugged in. Yours truly, a quiet subscriber. Thank you to all my quiet subscribers who watch and they never comment, they never send, they never write. Oh, look at this. This looks mint in box. This looks Soviet era. None of this newfangled Glasnost rubbish. Let's have a look. Oh, look at that beautiful confuser. Oh, that's fantastic. Ah, Rusky gold. Terrific. Oh, Look at that. None of this four-banger rubbish. Full scientific jobby. I have no idea what that says. And it's an MKU 41. It was mint in box and didn't work. Oh, boo-hoo. But look at the green vacuum fluorescent. I think you can see it. Vacuum fluorescent display in there. It's going to have some classic 80s Soviet era technology in it. Love it. Oh, flathead. None of that Phillips rubbish. Is it just the one screw? Is that another screw in the top? Is that wax? Is that like a wax seal in there? Could be. Let me try and dig that out. Just like the solar power video, more sludge on my tip. Nothing worse than sludge on your tip. Unbelievable. Anyway, yep, let's pop this baby open. Look at that. Spectacular. None of that solder mask rubbish. Look at the staggered pin jobby. I love those because they couldn't get the fine pitch back in the day, so they had to stagger them. Thing of beauty, is a joy forever. Anyway, 91. 1991. Or 88 and 91. It's got a mix. Yeah, the main chip, 91. Unbelievable. Wow. Hands up, Russian viewers, if you had one of these in 91. Jeez, I was still selling this in the 90s. Unbelievable. Look at the steel plate on those for each column. Wow, they went to town. Somebody had fun. Power supply's a Bobby Dazzler. Look at that. Wow, that's terrific. Carbon trimmer down there to set the volt. It's just got a follower tranny down there, and that's terrific. Little fuse down on the board. Wow, gilded the lily. Don't like the look of the display though. It's all black around there, and look at that. Look at that silvering on there. Is it like, it's almost as if it's some sort of like silver migration or something that's happened inside there. I don't know my vacuum fluorescent construction technology as such, but yeah, it looks like it's sort of like migrated halfway down there and then sort of, yeah, that doesn't look factory original to me. I think something's gone horribly wrong there. They let the vacuum out. Got to hand it to the layout person. There's no bodges on there. So yeah, that display looks like one sick puppy. I don't think there's much point troubleshooting that. I think that's Gonski. But if you do know for sure, let us know in the comments. But yeah, pretty simplistic designs. Basically single chip calculator. The rest is just like interface stuff for the display, really. Not much else doing there. It's all, I wonder if they developed their own, or did they like, copy early US or Japanese calculator technology or whatever. If you do know, please let us know in the comments, as always. I mean, I can't believe that was made in 1991 though. Wow, I mean, that was the year that the Soviet Union ceased being a union and became Russia. I mean, this is post-David Hasselhoff Berlin Wall. Unbelievable. And there's a genuine manual for those playing along at home. Absolutely fantastic. Beautiful. There's there's all the specs. Fantastic. And we do have a schematic somewhere in here. Look at that. You always get a schematic. Beautiful. Now that, a couple of flip-floppies up there. That's what those other chips on there would be. And oscillator. And I think that's it. Bob's your uncle. It's got something else. Is there another RC down there doing some sort of counting delay thing? I'm not sure what the deal is there. Have to sit down and think about it. Leave it in the comments. Anyway, thanks for everyone who sent something into today's mailbag. Sorry if yours is still sitting there, but you know, I just choose them randomly, really. Anyway, hopefully I'll do another one soon. No, I don't have enough stuff for every week, and you know, it's just not a thing. It's not a weekly thing anymore. But anyway, if you like Mailbag Monday, please give it a big thumbs up, because I will continue to do it regardless if you give it a thumbs up. But give it a thumbs up anyway. I need the engagement to feed in the YouTube beast algorithm. So anyway, as always, discuss down below. Catch you next time.